Hi, I'm Zach Thompson with Standard Comms, and we've worked with Extreme Endeavors to come up with the Smart Sound Perimeter. It's a rugged wireless network of acoustic sensing devices with the ability to give soldiers an unparalleled early warning, real-time intelligence, and perimeter security system in the field. Our technical partner, Extreme Endeavors, has more than 20 years experience deploying sensor-based solutions in harsh and diverse environments. They've deployed sensors in deepest cave networks in North America, in Antarctica, and we've even helped NASA to use infrasonics to detect caves on Mars. So deploy, detect, analyze, and retrieve. We deploy lightweight, rugged audio and infrasonic sensors designed to use very low power and gather sensory input. We give the soldier the ability to receive this data and process the information from the sensors on a handheld device that paints a picture of activity happening within the system and alerts its operator instantaneously to it. Once the unit's ready to move out, they can either leave that sensor system in place to collect information, or they can pick it up and redeploy it at their next location. So this is, I'm not the greatest PowerPointer, but so this is a map with 100 meters between the grid lines, and this is our little base camp setup. So the system consists of 3 different parts. The first thing, when a unit deploys, they're going to set up infrasonic sensors. That's represented by these 3 blue circles there. And those are going to reach out to a range of about 2 to 3 miles, giving detection ability out to that. The second thing they're going to do is establish a mesh network of audio sensors around their perimeter. These are going to be microphone sensors with GPS and battery dispersed and interconnected via low-power wide area networks using LoRa or long-range wireless technology. And the infrasonic sensors are all connected the same way. So here we've got them set out to about 300 to 500 meters away from the base camp. You could bring that perimeter out if you wanted to, just by adding more sensors. You could get more connectivity or a wider perimeter by staggering how you put your sensors. It's really up to the soldiers in the field. The wave data that we're collecting here could be anything, but we're specifically targeting movement and presence of man or machines. By networking these devices, we increase the reliability of the system and negate the loss of some devices in case they are destroyed, experience mechanical failure, or are taken out of action by the enemy. So we've envisioned presenting this to an operator in map form with objects and persons of interest displayed, but other forms of readout are possible. We could feed this data into augmented reality goggles so a sentry on the perimeter can see stuff coming before he could physically see stuff coming. It could be fed into a larger AI system that's receiving other forms of data, such as video feeds from overhead drones or any other conceivable electronic intelligence. So the device will emit warnings in case of perimeter incursion or based on any other guidelines that you give it. Activities such as digging, talking, crawling can be recognized, as well as points of origin for direct and indirect fire. It can identify unique IDs such as specific vehicles and small arms fire signatures. For example, let's say you're working around a village that just has a few regular vehicles. You can set it to trigger if they move at times they don't normally move, or if a strange vehicle enters your area of operations. So why 2 different sensor types? The audible range microphones pick up any normal ambient sound within a range of about 100 meters, depending on how loud it is. The width of the perimeter could be expanded beyond 100 meters using more robust sensor spreads. Triangulating the sound of someone walking between multiple sensors gives the speed and number of people walking, as well as the activity. The sound of those steps is going to betray if the subject's walking on gravel, grass, whatever it is. And it's going to feed all that data right back to the operator, and it's going to continuously improve the picture that they have of their immediate surroundings over time. It's going to pick up engine noises that are interpreted to be particular vehicle types, specific types of activities such as subterranean digging, manipulation of weapon systems, small arms fire. All of it can be triangulated in the same way to get the source of the sound and the speed and direction of travel. The infrasonic sensors or extreme low frequency sensors are able to interpret waves much further out, up to 2 to 3 miles in a rural environment and beyond. They're capable of interpreting data at a much finer level. They can determine unique signatures for individual vehicles just based off of, unique dents in the bodywork that create a different aerodynamic flow. So they can get really granular on that side. So future applications, long-term plans for the solution include configurations which can better integrate with other security technologies and systems, as well as enduring placements built around permanent hubs. Enduring sensor placements around permanent infrastructure could be linked to cloud-based software with deep learning component, enabling the system to learn from big data coming in from multiple systems. Think hard buildings, installations along major roadways, pipelines, waterways, and even borders. We can airdrop sensors in places where we don't have troops to gather info on troop movements or any other activity that's happening in those areas. There's a ton of possibilities. While smart sound would be a powerful tool and force multiplier as a standalone system, its greatest utility really is for the special operations community lies in integrating smart sound with the technologies and capabilities we already have available to our teams. It'd be hard to imagine any team deploying in this day and age without precision magnifying optics, night vision, thermal technology, motion activated cameras, non-organic ISR assets, and various mobile SIGINT platforms. But all these tools, as wonderful as they are, face inherent limitations. For instance, all the visual enhancement and detection capabilities I mentioned require a line of sight, so they become less effective in situations where terrain features, weather conditions, and deliberate camouflage conspire to conceal enemy activity. Strategically deployed smart sound sensors can help to fill that gap. Imagine a scenario where a team, by virtue of smart sound perimeter, is able to hear individuals on the far side of a ridge before you could ever sight them using any known technology. Or where smart sound alerts the team to the sound of digging at an odd hour. Whether teams decide to react to that information by alerting a sentry, organizing a patrol to investigate, or requesting the help of available ISR assets, that's information they're going to want. For the sake of brevity, I made it easy on myself and presupposed in my examples the activity smart sound detected was something that would clearly be important to the team in the field. That's our goal after all. We want to filter out from a bunch of sounds and instantly discern the acoustic anomalies or patterns important to the team and clearly convey that information. How discerning can we be? The short answer is very, like the vehicle signatures that I told you about. The longer answer is it depends. The longer this system is deployed in a given area and the more data we give it, the smarter it's going to get. If you're interested in learning more, please feel free to reach out to me and we can dive deeper with an engineer. I'm happy to take questions if we have any time left. All right, thanks.